Hello everyone. Today we're going to take a look at this Bentima battery clock. It's not a quartz clock, it's not an electronic clock, it is an electromechanical clock. Hence why it just says battery on there, because I think back in the day a battery powered clock was something very new. Case is made out of tin. But it's not your typical tin clock. So, story with this clock is that it fell on the ground. As you can see here, it's a bit bent, but first it survived pretty good. And the glass is broken. However, that's not the only thing that's the problem. The watch hands have an intermittent problem. Sometimes they will move with the movement and keep time correctly, and then other times they just do nothing for days on end. So I assume that either something broke in the hand mechanism, or there's just like something that went out of place, went loose. So yeah, let's get the watch hands off. So in order to get the movement off, well, let's see, can I get the hands off easy? Edge screw is coming off, yes, okay. That one comes off, this one should just slide off with some persuasion. Okay, and let's see, is this... Yeah, that one comes off too. Seems like... Oh, dial can pop right off. Okay, and then we need to get the movement out from the back. Okay. So we have the movement, a bunch of spaces, oh yeah, and then we have the movement itself. Yeah, I can already tell that like it can definitely use some cleaning, because that amplitude is next to nothing. So let's zoom in on the movement and we'll get going. So before we attack the movement, let's just well, take a look, close-up look. So it's a bit hard with reflections, but you can basically see balance, a few coils. Here's the adjustment, battery contacts. This is to adjust the watch hands. It's the annoying type. It's like a button you need to push and then turn. And yeah, this is the side where like going to undo those 3 screws, and we'll go from there if they want to. My screwdriver is a bit too wide. Let's see, is this one better? Yes. Looks like they're pretty long. No, not that long. Maybe the whole thing comes out. Oh, I see. There's screws here too. In the other direction. Oh, now I get it. So, these screws were holding the movement against this plate. And those screws were actually holding the movement. No, the plate in place. But that's not a big problem. Because if we open this now, everything should come loose, I think. And now. Okay, and now we are in. So here we can clearly see circuitry, balance, coil in the middle. It's only one coil, but I can see different colors of wire, so I assume that all the windings are in one. And then there's the tiny movement in between, and this is what is going to be our point of attention, because that's what's not working as it should. Because I assume that this, yeah. So this is where the hand tension is on this part here, and it does move rather loosely. So I don't know. There's not a spring, or is there? Yep, there is a little spring in there. So yeah, probably not yet sure on this one, but we'll take a look at it, and I will let you know, or I will show you what I'm going to do. So yeah, till then. So here we are back with the movement, and basically while I was inspecting it, like the hand tension is like on that gear here. We'll show it on the microscope. You will see it a bit better under there. I couldn't really see anything wrong with it. It's like a kind of flat spring that's being pushed against the gear. It's kind of a system that usually doesn't really break, although it can. Let's get that watch hand on again. So then I was turning it. Oh, is this? Yeah. There it is. Then I was turning it like I'm turning it now, and I noticed that like sometimes it would seize up. So I was like, wonder. And then like just literally the tiniest amount of oil solved it. So we found our intermittent problem. So this plastic gear would seize up under like, I don't know, a certain point, because like if I look at it, I can't see any damage to it. Come on. Like, it is pristine condition. Like, no damage on any of the teeth. No damage on the back. That's just like letters and a bit of mark from production. So yeah, the tiniest bit of oil solved it. And yeah, I have a very strong suspicion that was the problem. Because if this seizes up, then the movement still ticks, because that was what the problem was. Movement still ticks. Watch hands do nothing. So yeah, that's an easy fix. I'm going to hop now over to the microscope, so you can see it in a bit better detail. So, see you there. So, here we have the movement on the microscope. I need to show it from the side, because there's no way, once I open up the movement, that I can demonstrate like what's going on. So, here we have basically the escapement, so you can see the coils and the magnet, and then here there's kind of a worm gear, and then this gear has really weird teeth on it. So every time the worm gear passes, this gear will click one step ahead. And then from here you can see it go into the movement itself, and then it goes onto here, which is the gear of the seconds. So on here there's a very long axle which goes all the way to over here, where optional there could be a second hand. From there it goes over to down under all the way at the back, which is your reduction gear. And from there it goes to the like minute gear. And on the minute gear you can kind of see, if I don't put my cast a shadow, you can kind of see over here there's a really tiny spring. And that's because there's no connection, like no fixed connection in between the axle and the gear itself, except for that little flat spring. So that little flat spring is actually pressed in between the axle and the gear, allowing it to slip, because in order to change the watch hands of position, of clock hands in this case position, you need a bit of slip, but of course it can't be too much, or you can't move it, or it can't be too loose. Otherwise, the watch hand wouldn't move correctly to keep time. And because on the front the hand mechanism was seizing up, of course that allowed it to spin freely. But that's fixed now. So yeah, that's the basic overview of the movement. Now let's turn it around and I'll show you this special gear in action. So change it around now and let's give it a spin, because I can't really have it work. So let's give it a bit more beans. So as you can see, each time the worm like gear goes back and forth, it will move the teeth of this gear one step, and as typical with a worm gear, there's not really a way to feed it back. So yeah, you can see it's basically like 2 turns of the worm gear. And what's also a bit odd about this little clock movement is that the power comes all the way from the metal parts of the main plates of the movement. So you can see one contact for the battery is here, and the other just touches the movement, and then through this screw here it gets its power from the movement. It's probably so low power it doesn't really matter, but I still think it's a bit odd. There's also and that's even more weird, there's also some of the power, like is this a grounding lead or something like that? So basically this is connected to the circuitry, and it just rests on the axle of the movement. So I don't really think it's a switch kind of type, because, well, that would mean that like you would only need one coil here, but we can clearly see there's two. So I don't know, because like using a switch contact like this was something that was done in the very early electromechanical watches, and I presume clocks too, but that's not something I expect to see here. So yeah, let's turn it around once more and I'll show you the adjustment. So now we're watching top of the movement, and so here you can basically see like this is the screw you would turn to adjust it. So you can see there's basically a screw in here, there's some screw thread on there, and it moves this back and forth, which lengthens or shortens the effective length of the hairspring, and that's regulating the clock in this case. This is something you see very commonly on a lot of those electromechanical clocks. But anyways, that was it for this video. I hope you liked it, and let's see you in the next one. Bye bye.